it's working. Perfect. Okay, thank you. And it's been a very interesting talk so far. I'm maybe touching upon a few themes that have already been mentioned, but I'm going to focus more on the edge and the user than, say, the overall network. So basically, I think we've already had a talk about AI and machine learning, so I'm not going to say much in this slide, but I think this kind of illustrates how deep learning is a subset of machine learning. Machine learning in turn is a subset of AI. And let's just remind ourselves, because I'm going to use the term AI really as an umbrella term, but AI is computing systems which are capable of performing tasks that humans are very good at. For example, recognizing objects. And machine learning is a field of AI that applies statistical methods to enable computer systems to learn from the data towards an end goal, coined by Arthur Samuel in 1959. Now, a lot of the advancements in the real world in AI are really coming from machine learning, and in particular deep learning. And deep learning from 2012, when AlexNet, a team of PhDs and Toronto University won the ImageNet competition, and we've seen an explosion in areas like convolutional neural networks with object detection, transformers with natural language processing over the last year or two as key examples. Another key point I'll make, just for point of reference, is that the AI that we have today is narrow AI. It's good at performing a specific narrow task rather than artificial general intelligence that the newspapers and the media scare us about, that's going to come out and replace humans and do everything we can do better. It doesn't exist, and we don't know when it will occur. Coming into 5G and edge computing. So 5G is a revolutionary technology, and it's going to work very well with AI, and we'll come on to that in a moment why. But what are the key features of 5G that make it so important and game-changing? Well, the speed aspect that is being mentioned, which is that the average 4G speed leads to ultra-low latency, 1 millisecond to 4 milliseconds of latency. And that means we can start doing things near real-time, more or less, on the edge, on the device, real-time analytics, real-time interactions. If you think of an autonomous vehicle, an autonomous robot, robotic surgery, it needs to make real-time interactions. Otherwise, if it's waiting for a response from a remote cloud server, half a second, 1 second, it will crash or kill someone. So we need that real-time engagement. Technologies such as augmented reality and virtual reality suffered with latency with 4G. Now with 5G, with the ultra low latency and also new standards like JPEG access, they'll start to work as intended. And crucially, 5G allows a lot more device capacity on the network relative to 4G. Often you'll find your 4G network wherever you are in the world. You're often dropping sometimes. 4G networks are to 3G. 4G networks are maxed out in capacity pretty much everywhere or in most locations. 5G, depending on who you believe, can handle up to 1,000 times more device capacity per square unit of measurement. And that's going to be very important when it comes to things like IoT. So the edge, what is the edge? Well, we see here the cloud. We're all familiar with the cloud, I believe, remote cloud service somewhere remote. And the cloud will continue even in the 5G era. It may be that we're going to be more towards hybrid systems. And what's the hybrid going to be? It's going to be that you still train your AI, your machine learning on a cloud and a big data set, and you may probably use the cloud for historical data lake for storage of vast volumes. But the edge is where you're going to do things, where the AI is going to be inferencing, the machine learning will be inferencing, making decisions closer to where the data is processed, closer to where it's generated on the devices of the consumer and enterprises, which means that we're going to open up a whole new area of interaction and capabilities in terms of products. The imagination really is the limit. Now, the previous speaker mentioned a 75 billion figure, and I think this kind of illustrates it nicely and why we will need machine learning and why it's going to fit very nicely with 5G. Statista forecasts by 2025, we're going to have 75 billion connected devices. What does that actually mean? That means 9 devices per person on the planet, connected devices. We're going to need machine learning to make sense of that, and deep learning, etc., to make sense of that data and provide meaningful interactions. It's a dramatic increase, and you can see this slope of the gradient from 2022 onwards as 5G rolls out and we get more and more capacity on the network and many more devices are going to get connected. Massive increase in big data, as you can see here from this chart. Again, in a data-driven world and this vast amount of data, that's where machine learning, deep learning really has the edge on humans. The data is too big for humans to process and find the hidden patterns in that data. Interloven point out that in the entertainment sector, for example, $1.3 trillion, 1.3 trillion, emphasize that, will be generated from 5G related services. And 2025 is a point where it dominates in the media sector. But you can see that 2022 is an inflection point, and 2022 to 2025 is where you really get this steep gradient, as you saw with the devices as well before connected devices. So that kind of gives you a flavor of the market size and potential. It's going to affect pretty much all sectors. This is from Boston Consulting Group, and it shows how manufacturing sector is going to have pretty much the ghost in the machine. We're going to have automated manufacturing with predictive analytics in the machines, communicating real time with each other with IoT sensors, and the ability to predict things going wrong before they actually occur. We're going to have digital twins, which allow you to plan for your factories and scenario test and kind of get rid of problems before they occur in the design stage. And with the IoT sensors and the predictive analytics, we can predict unplanned outages, take proactive measures, and therefore stop interruptions to production and also extend asset lives, because these machines are often very expensive. A robotic arm could be anywhere from 10 million to hundreds of millions in terms of costs. So if you can predict unplanned outages, not only do you reduce damage to your business interruptions, but you also and increase output, but you can also prevent damage to your machinery. At the consumer side, we're going to get a lot of new interactions. Holographic glasses are going to be key. You see many of the tech majors, Facebook, Apple, etc., Samsung, are pushing into glasses. Google have been doing it more on the enterprise level, or making plans to launch those. And so we're going to get completely new forms of consumer interaction that we can't even imagine right now. And if you think of the COVID-19 crisis, we've been increasingly reliant on digital, right? Many of our meetings have been occurring through Zoom or other mediums, and hence going to glasses technology in 2 or 3 years from now, when it's going to open whole new types of interaction. Here I showed an example of music and how consumers may be interacting holographically with their favorite artists, and purchasing merchandise, etc. E-commerce, everything will be completely disrupted. You'll get this highly personalized, deep interactions. Autonomous cars are going to require 5G to really take off, to engage in machine-to-machine communication, but also the interaction for consumers, the user inside the car, is going to be very much driven by technologies like mixed reality, augmented reality. Mixed reality is like AR, but you can actually interact, the user actually interacts with the virtual object. And that's going to allow for real-time engagement with the customer. When the car's driving itself, the customers are inside, they'll be doing work, maybe they'll be planning their shopping or whatever, etc., entertainment, and you'll be able to engage with them real time. A lot of new opportunities arising that we don't have today. Again, autonomous vehicles are going to struggle with 4G. You need vehicles to communicate with each other on the edge, on the device itself. If a car is waiting to turn left or right and waiting for a signal back from a remote cloud server, it could crash, or the vehicle behind it may crash. So you see here in this example, the car at the front is damaged, but the vehicles behind, even if they don't have line of sight of it, it's been broadcast to all of them that there is a damaged vehicle, and they can all avoid the broken down vehicle. So it's basically vehicles telling each other what they're going to do before they do it. If I'm 3 vehicles in front and I'm the autonomous car, and I'm telling everyone, I'm going to brake, or I'm going to turn right, or I'm going to, accelerate, everybody knows the vehicle in front, the vehicle behind, the whole network, we can optimize and make, whether it's deep reinforcement learning or deep learning, making decisions with multiple agents to interact and respond accordingly. That's the kind of world we're going into. And if someone detects a pedestrian walking out, to broadcast to everyone that there's someone there. Healthcare is going to be completely transformed. Machine learning with drug discovery, clinical testing, it takes a long time to get a drug into production. But with clinical testing, for example, and edge devices, sensors, etc., all around us, we can gather real-world evidence, real-world data, and then use that to facilitate and accelerate getting a drug through approval in the clinical trials. Computer vision on the edge with for accurate diagnosis. If we can combine convolutional neural networks onto the edge, onto smart cameras, onto mobile phones, and help a doctor. So, for example, in the UK and elsewhere right now, as an example, general practitioners in primary care are often not allowing their patients into the practice because of COVID-19, and everything's being done remotely on video conferencing. But if we can enhance that by putting computer vision onto the edge and helping the doctor, detect things on the patient, that's the kind of world we'll be going into, with interactions with NLP and electronic health records, with transformers, etc., on the edge. Language translation real time, so that language isn't a barrier. Robotic surgery is a very good example, though, of what we can actually do with 5G already today. In 2019, in China, remote robotic surgery on the brain surgery was conducted with the surgeon 3,000 kilometers away from the patient. Real-time brain surgery successfully completed. And think about that. Federated learning was mentioned before, and the issue of data privacy, and security. So, of course, as we go to this world of real-time interaction with the customer, machine learning on the edge, it's very, very much data-driven, and of course, being able to access decentralized data is going to be key. What is federated learning? It's a technique, relatively new, launched by Google a few years ago. We've got techniques from TensorFlow, federated, and also PySift out there using PyTorch, led by an academic in Oxford University, and others. And why is it important in this area? Well, the concept works on the basis that you start with a globally trained model like you do today, train on the cloud, deploy it onto devices, could be mobile here, for example, because a lot of mobiles are going to have GPUs going in the future, in the next few years. And then you train on the localized data. But crucially, you don't remove the data from the device. The device stays on the local device, but you update the weights and the gradients, the mathematical parameters or properties of the model, back in the global model, and redeploy back. And that allows you to basically do decentralized learning, learn from aggregated learning from multiple devices, multiple customers, without removing their data. And if you put encryption on both ends of the communication, you can secure it from adversarial attacks that might try to get in and reverse engineer the data, or reverse engineer from the parameters. So this is going to be a technique that's going to be very important going forwards to ensure data privacy and security, and will have big impacts in areas like healthcare, as well as personalizing services for users and security as well. So an example is the work that NVIDIA have been doing with King's College London and others on using federated learning from decentralized servers, where you can go into different medical centers, access different records, and then learn about an individual patient, for example, aggregating the machine learning so that you get a holistic picture of the customer. And that's been a big the patient, I should say, in this case. And that's been a big problem for machine learning in healthcare. A lot of money's gone into it, but many have struggled to scale successfully, to be very honest, because of the data being fragmented and difficult to access and concerns of data privacy. Longer term, of course, 5G is going to be a huge opportunity for us. This growth at the edge and devices and new services, we should also think about the fact that COVID-19 is triggering a global recession or possibly even depression. We're going to need policy. We're going to need policy responses globally to get people back to work, to get the economy going again, but also to deal with the climate crisis. And the likes of PwC and Microsoft has shown on the left-hand side the scope that machine learning can have, AI can have, on stimulating sustainable economic growth in areas like agriculture, energy, etc., where edge computing and 5G will really be fundamental in driving a lot of the innovations and new businesses. And Accenture's strategy on the right-hand side, if we take the US, the United States as a proxy, has shown a kind of job creation that we can get. And if you think about it, a lot of the disruptive startups often came when the new Gs came, when 3G came, when 4G came, you know, Uber, etc., and social media applications, messaging applications really took off as we got each of those new Gs. And when 5G comes, although a lot of the focus right now is enterprise with startups, I do believe it will create a new window of a year or two for the next new wave of unicorns or future Googles, etc., to emerge. We can't really predict who they're going to be.
1 minute to wrap up, please.
Perfect. So the future of AI, I believe, is going to be highly exciting. A lot of potential for new opportunities on the edge, real-time interactions, security and data, accessing that will be key, of course, and data privacy with regulations. But we're going to see a lot of opportunities, and which are going to be for collaborative technologies and new innovations. So I wanted to keep it high level rather than going into detail, because I think a number of the other presentations will be detailed. And that really is summing up what I had to say. Handing back to you.